If you take any number to the 0 power, you put any number to the 0 power, what do you get? 1. Remember, any number to the 0 power is 1. So today we are starting logarithms and logarithmic functions. Has anybody done this in a different course? And I don't mean a different math course. Like somebody told me engineering, maybe.
I did it my old school. I don't remember when you but I don't remember how to do it either. I just
Well, I'm gonna teach you. For most people, what? What'd you say? Yeah, I thought, and I'll show you that. That's not gonna help you for all of this. Yeah. So for most people who do their work, this is going to be really easy. If you don't do your work, you're going to be so confused because you've never done this before, and it's going to seem really foreign. So as I'm teaching it, if I put stuff on here, then and you don't know what I'm talking about, like ask right away, and then do your assignment. So today, you are learning what a logarithm is. So we have been studying exponential. Here's an example of an exponential equation. And in the first section, we had a problem where you just solve for the exponent. But we have never learned how you can cancel out a base and get an exponent by itself. In order to cancel out a base and get an exponent by itself, people had to develop something that does that. So they called it logarithms. And what logarithms always equal, you can see right here, it's the x, what logarithms always equal is the exponent. Always. Something else that you compare with the exponential and this logarithmic function is this little b down here is the big B over here. That is called the base. So when we talk about exponents, that is the base with an exponent. Down here, it's called log base b, or whatever number it is. But it's called log base, that number. So it's the base with the exponent, and it's the base of the log. It always equals the exponent. So those two things make the logarithm. And then y, the value that's in the y spot, goes next to the logarithm. You're going to read this. You're going to read it as log base b of y equals x. You say log base b of y. Say it once. Log base b of y. Okay. So now we're going to take these logarithmic equations and we're going to change them into exponential form. They're going to be completely equivalent to each other, just a different form. So when we look at this and I say, what? Well, first of all, let's read it. It's going to say log base 2 of 16 equals 4. Okay. So when you say log base 2, I say, what is the base? 2. So that becomes the big number. And I say, logs always equal the exponent. So what's the exponent? So to rewrite this into exponential form, you write 2 to the 4th equals 16. And then you say, is that true?
No.
Please don't say I don't know, because we're doing 2 times 2 times 2 times 2.
It's true.
Okay, if it equals, then you probably did it right. So this one, let's read it. Log base 4 of 1 equals 0. What's my base?
4.
So what exponent? Equals, and it's 4 to the 0 power 1. It is. Next, let's read it.
Log base
or base?
12.
Exponent.
1. 12.
Is that true?
Yeah.
Okay, last one. We've got what base?
Log.
I just what base?
Oh,
Exponent.
Reciprocal.
So if I reciprocate 1/4, does equal 4. Okay, so all we're doing is taking this form and changing the form, but they're the exact same equations, just written different. Now we're going to rewrite these exponential into logarithms. So I'm going to say log base, what's the base? 5. Of some number equals the exponent. So what's that some number? Yes, please. So I'm going to say for this one, log base 10 of, not 2 though, of 0.1 is equal to -1. 2 though means it's like an exponent. But of is what we're taking the log of. Okay, I have something else to say about this one. Do you remember, just off little tangent over here, do you remember when we do square roots, do we put the 2 there? Why? We don't need the 2 there because if you see this, you already know that's a square root because it's just like accepted that that's the common thing. So log base 10, you will not necessarily see the little 10. You're going to see it written like this. It means log base 10 because log base 10 is the most common. Because what do we count by? 10. So I use the most common. So when you see log without a little tiny number down there, it means log base 10. So when you don't see the number, it means 10. So now you were asking about the calculator. And you guys go ahead and take out your calculator so you can see it with me here. So you look at your calculator, and in the first column, you will see there is a log button, but it does not have a base. So this log is base 10. So if I typed in log, what was that? Log 0.1. If I typed in log 0.1, it equals -1 because that's what it's supposed to equal. Because that's log base 10. And if you look right above the log button, the inverse, you see it says 10 to the x. These are inverses of each other. This is base 10, and that's 10 to the x. Okay, next. C. Log. What base? Of equals 2/3. D. Log. What base? 6 of 1/216 equals -3. So let's just rewrite it. Somebody doesn't do their homework, then they have no idea how to do it. Okay. That's it. Next, I just was talking about a common logarithm. It's a logarithm with base 10. I was just talking about that. If you need to use log base 10, you're gonna just write log. We don't write log base 10 because we all know that's a common logarithm, so we write log. There is something called a natural logarithm. If you keep reading, a natural logarithm is a logarithm with base e, which is the natural number. So if we ever want to do log base e, we don't write it as log base e. We write it as ln with no base. ln stands for natural log. Well, I believe the word is in Latin. L comes first or something, I think. But it is natural. I don't know what the word is actually, but it really seems to. So you look back at your calculator, and when we were just doing E the other day, what is the main button for E? LN, because they are inverses of each other. They undo each other. Not every button, but look at the x squared button is the square root. You know what I mean? It's not every button, it's just some buttons.
Very underwhelming. I was so shocked.
All right, we are going to evaluate each of these, and evaluating them means to find one value, one answer. So I'm going to have log base 4 of 64 equals a number. What do logarithms always equal? The exponent. So what you want to think to yourself is 4 to what number is 64? Do you know that answer? It's the third. So my answer is 3. Yep. So you just solved for an exponent. So this one is going to be 5. And you know what? I don't like using question marks. I'm just going to call it x. 5 to some number is 0.2. But it might be hard to think about it that way, but if we take 0.2 and we make it into a fraction, it's going to make more sense. If I do 5 to some number equals, what's the fraction for 0.2? 2/10, which is 1/5. What's the exponent? -1. So that's my answer. My answer is not x equals -1 because there is no x in this question. I put the x in myself. It's easy. I think tomorrow's. No. I think tomorrow's is okay. A teeny bit. It's not too bad. The only people that had trouble last year were the ones that didn't do their homework. I'm not lying to you. I'm not lying to you. Okay, how about this one? 1/5. This one might be a trickier one. 1/5 to some exponent is equal to 125. Now, you might really understand your exponents and be able to tell me this answer, but I will show you a backup plan. If you can't look at this and figure it out, I have a backup plan. What I'm going to do is I'm going to rewrite both sides with the same base. Rewrite both sides with same base. So when you look at 1/5 and you look at 125, and we talk about rewriting with a base with an exponent, I'm thinking 5 would work for both. So how would I write 1/5 with a base of 5 and a certain exponent? 5 to the what gives me 1/5? And there is still that x up there. Then I'm going to rewrite 125 the same way. I'm going to rewrite it with a base of 5. 5 to the what? Third is 125. Okay? So, and I can simplify that a teeny bit. I'll just say when I have a power to a power, I just multiply my exponents. So I have 5 to the negative x equals 5 to the third. And then I'm going to use what's called logic. And I'm going to say, if I have 5 to an exponent, and that equals 5 to an exponent, the exponent's got to be equal. It is logic. And I can show you how to actually solve that once we learn more about logarithms, but you guys can just make this assumption it's true if they have the same base. So what's x equal? -3. So remember, when we think about that going back in as the answer, if I do 1/5 to the -3 power, 1/5 to the negative flips it, and third takes it to the third power 125. So it works. And you might not need to do this if you understand your exponents. I'm going to do that same thing for D. So I'm going to first think 36 to some power is going to be 6. And I'm going to say, I'm not sure about X. So I'm going to put both sides so they have the same base. What base do you think that should be? 6. Because what's 36? 6 what? To the second. And then this 6 is just 6 to the first. So if they have the same exponents, the same bases, then their exponents have to be equal to each other. So what's X? Solve that equation.
Oh my God, Dad.
Wow, that's
So divide by 2, what's X? So let's think about what that means. That is the answer. Let's think about what that means. That means 36 to the half power is 6. What does the half power mean?
square root.
It means root.
Square root.
The square root. It means the second root. Is that 6?
Yes.
Okay, next is a calculator question, really simple, easy calculator question. It says evaluate, question A says log 8. What's the base? 10, because it's not there. So you can use your calculator, you just hit log 8, enter 8, and what'd you get? Just 0.9, it says 3 decimals. Okay, part B is ln 0.3. So you type on your calculator ln 0.3, enter. Ellie, what'd you get?
Negative 1.24.
And two decimal or 3 decimal places would be negative 1.204. That should be really easy.
Is that for homework going to be like?
Yes. Okay, so these are all review of what we just did.
Yeah.
Wait, we got one more thing. Okay, this is the last thing. We're going to start talking about how these are inverses. Remember on the calculator how it was like the long button had 10 to the x above it? These are inverses. Inverses are also like multiply by 2, divide by 2. They undo each other. Or if I added 10, what would inverse that? Subtract 10. Or if I did the square root, inverse would be squared. So 10 to the x, inverse is log, base 10. So you can simplify this without using your calculator. And you're going to need to know how to do it without the calculator because when you look at the next one, that's base 5. So this is saying 10 to the log base 10 of 4. How do I know that's base 10? How do I know that's base 10? Common logarithm. There isn't a little number written there, so I know it's base 10. If I have 10 to an exponent, and in that exponent I have log base 10, they undo each other. They cancel each other out, and I get what left over? It's just 4. Oh yes, the answer to A. The answer to A is 4. Okay, part B is log base 5 of 25 to the x. Now this one's a little bit different. This one has a base 5. Log base 5, what would be the inverse of log base 5 is going to be 5 to the x. These would undo each other. This is not 5 to the x, but it could be written as 5 to the something. 5 squared, right. So I'm going to rewrite this as log base 5 of 5 squared, and then that x is still there. Because we multiply our exponents together. So when I do that, I now have log base 5 and 5 to the, which cancel each other out. And what do we get for our answer? 2x. Let's try a couple more of those and we'll be done. 13. We've got 8 to the, and in the exponent we have log base 8. And then an x. Are these inverses of each other? They cancel. What do we get? That's it. 14. We've got log base 7 of, and then we have 7 to something. Negative 3x is the answer. How about 15? We've got log base 2. But 64 is not 2 to an exponent. But it can be written as 2 to an exponent. To the 6. And then we put that x there too. So what is this answer? 6x. And then remember, e to the and natural log ln are inverses of each other. They're on the same button on the calculator. So e and ln cancel each other out, and we get 20. All right. Yeah. Hey, ladies and gentlemen, hold on. He has a question, and you might have that same question, but not realize it yet.
I'm confused on why someone
It's just something for me. Okay, well this one I have an X in here. So this one, the log base 2 and the 64 becomes 2 to the 6. Like that will cancel. Let me do it in a different color. The 2 to the and the log base 2 cancel each other out. So whatever is left is my answer. There happens to be an X in it. Just whatever's left is your answer.